When the first full-color launch image sent back by the Webb Telescope appeared on the screen, astrophysicists around the world did not cheer. Instead, they fell into a collective and prolonged silence. That kind of silence was the sound of cognitive collapse. Strictly speaking, this machine is no longer just a telescope. It is a real-time machine. Due to the limitation of the speed of light, the farther we see, the older the past we are seeing. Webb's vision is enough to penetrate dust across 13.4 billion light-years, directly gazing at the moment only 400 million years after the Big Bang. According to the Big Bang cosmology that humans originally firmly believed in, the universe at that time should have been like a newborn baby, chaotic, scorching hot with only a few scattered, unformed clouds of gas. However, the images sent back by Webb slapped humanity hard in the face. In the universe 13.4 billion years ago, it was actually full of adults. Those galaxies that should still have been in swaddling clothes had already developed to an extremely mature state, possessing perfect spiral structures, some even larger than today's Milky Way. There are only two explanations. Either these galaxies collectively traveled through time, or the universe model that humans take pride in, from the root, was fundamentally miscalculated. Overturning cosmology was only the beginning of Webb's Feng Kuang performance, but the very existence of this machine is an engineering miracle, even a huge gamble that stakes humanity's spaceflight credibility. It is 1.5 million kilometers away from Earth, located at the second Lagrange point, 4 times the distance to the Moon. When the Hubble telescope broke down back then because it was close, the United States could still send space shuttles to repair it and change its glasses. But Webb is different. Once it was launched, there was no turning back. No spacecraft can fly that far for maintenance, and no astronaut can go there to tighten a screw. This is equivalent to humanity spending $10 billion to build a camera with absolutely no after-sales service, throwing it into deep space and betting that it will never fail. What really makes engineers' scalps go numb is Webb's extreme working environment. Webb's core mission is to capture infrared light, because due to the expansion of the universe, the light emitted by ancient galaxies has been stretched into infrared wavelengths, and infrared light can penetrate cosmic dust. But any object with a temperature will radiate infrared light. Imagine you want to use the thermometer gun to measure the body temperature of a firefly 1,000 meters away, but the thermometer gun in your hand itself has a raging fever. What you measure is entirely your own temperature. You cannot see the firefly at all. In order to see that firefly from 13.4 billion years ago, Webb had to cool itself down to the extremely low temperature of minus 223 degrees Celsius. So scientists put a golden bell armor made of polyamide on it, 5 huge layers of sun shields. When fully unfolded, this sun shield is as large as a tennis court. Yet each layer is as thin as a strand of hair. Even being pierced by a tiny grain of sand would greatly reduce its insulation effect. However, these 5 layers of film created a miracle of physics. On the side facing the sun, the temperature reaches as high as 85 degrees Celsius, hot enough to boil an egg, while on the side facing away from the sun, the temperature plunges to minus 233 degrees Celsius, cold enough to freeze nitrogen. Over the next 10 years, this machine will endure every second of every minute, both hellish heat and the extreme cold of deep space at the same time, with a temperature difference of up to 300 degrees between the two sides. Besides being afraid of heat, Webb also faces a physical problem. It is too big. Its primary mirror has a diameter of 6.5 meters, taller than a 7-story building. No existing rocket fairing can fit such a large mirror. So engineers came up with the most Feng Kuang plan in the history of spaceflight: folding. They cut the primary mirror into 18 hexagonal mirror segments, coated them with gold, and folded them like origami to stuff them into the rocket. But this was not the hardest part. The hardest part was the deformation process after reaching space. After deployment, these 18 mirror segments must be assembled into a perfect curved surface, with a precision error no greater than 10 nanometers. The entire deployment process was broken down into 344 critical steps. These were called 344 single points of failure. If any one latch failed to release, if any single cable, if any cable got stuck, $10 billion would instantly turn into space junk. There was no backup plan and no second chance. After officially being powered on in 2022, Webb seemed to switch into overdrive, Feng Kuang reshaping humanity's worldview. First, it discovered candidate dark stars that theoretically should not exist. These points of light shine as brightly as entire galaxies, yet they may be single supermassive stars powered by dark matter annihilation. If confirmed, this would be the greatest breakthrough in physics in 100 years. On Jupiter's moon Europa, Webb detected carbon dioxide on the surface of the ice shell, suggesting that chemical reactions may be occurring in the liquid ocean beneath the ice. And that is the foundation for the emergence of life. In 2025, Webb locked onto a planet located in the habitable zone of Alpha Centauri, the star system closest to us. The conditions there may allow liquid water to exist. However, from the moment this great explorer set off, its lifespan began counting down. Unlike Hubble, which can adjust its orientation in low Earth orbit using Earth's magnetic field, Webb must consume fuel to maintain its position and orientation at the L2 point. The fuel it carries can sustain it for about 10 years, perhaps up to 20 years at most. The day the fuel is exhausted will be the moment the mission ends. Faced with the subversive data sent back by Webb, astrophysicists did not avoid it. Instead, they began to re-examine and revise existing models of the universe. Some scientists proposed there may exist a mechanism of rapid expansion in the early universe that allowed galaxies to complete rapid evolution in a short period of time. Other scientists believe that the effect of dark energy may be stronger than previously predicted, accelerating the process of galaxy formation. Although the new theories have not yet reached a consensus, the impact brought by Webb has undoubtedly pushed the progress of cosmology forward. As Nobel Prize-winning physicist Adam Rees said, scientific progress often does not come from confirming existing theories, but from overturning them. The appearance of Webb has made us realize that humanity's understanding of the universe is still only the tip of the iceberg. Even now, the Webb Telescope continues to take hits. In May 2022, a micrometeoroid struck the C3 segment of the primary mirror at high speed, leaving permanent damage. Such impacts will only become more frequent in the future. Webb is like a war photographer persevering amid a hail of bullets, long prepared for sacrifice. 10 years from now, when Webb completes its final observation, it will forever drift in that cold, silent deep space, 1.5 million kilometers away from Earth. It will not return, nor will it have a tombstone, but every image it sends back will become an eternal monument in the history of human civilization. Perhaps in the future, humanity will launch more advanced telescopes that surpass Webb's observational limits. Perhaps humanity will find more accurate models of the universe and completely unravel today's mysteries. But Webb's contributions will never be forgotten. It is like a pioneer who lit a lamp in the pitch-black universe, illuminating the path of exploration for those who come after. The Webb Telescope has shown us that what we thought we knew about the universe was only the beginning. As this lone observer continues to decode the cosmos from the edge of deep space, one question remains: what else is hiding in the darkness? If you enjoyed this deep dive into the unknown, make sure to subscribe and join us on this journey.